Hi all. So let's solve this question. This question is basically saying that how can we use quantifiers in computer science? So read this question carefully. The question is saying in the following program segment, a program segment is given to you. N is integer variable, this variable n, this is integer variable, and this variable a, this is an array. This is an array of size 20 of 20 integer values, and you can see the index is starting from 1 to 20. So index is not starting from 0, index is starting from 1 to 20. A1 to A20, these are the values in this array. Now we are saying that the following statements, some statements are given to you, these 4 statements are given to you. The following statements about array A can be represented in quantified form. So all these statements that are given to you about array A, we can convert them into quantified expressions. Now the question is saying the domain is all integers from 1 to 20. So this is important point, that domain, here remember the domain is a set of all integers. So first of all, in the domain, in the universe, in the domain you have 1, 2, 3 and so on 20. So these are the values in the domain, means whatever variable you will take, that variable, whatever variable you take, x, y, z, whatever variable you take, every variable will refer to this domain. Okay, so very simple. This is the domain. So your domain consists of all integer from 1 to 20 inclusive. Means in the domain we have 1 also, we have 20 also, 2, 3 and so on, everything. Now what we need to do? We need to convert these statements, 4 statements are given to you. We need to convert them into first order logic expressions. So let's do it one by one. So let's start with the first one. The first statement is saying every entry in the array is non-negative. What this statement is saying? This statement is simply saying that every entry in the array, remember A is array. So in the question you have this A, this is an array. So you can see this A is an array, this is the array. And in this array you have basically total 20 integer values. These are the index 1, 2, 3 and so on 20. So you can notice, for example, here you have some value. Okay, let's assume here you have value, maybe here you have value 99. So you can notice this, what is this cell? So this value I can simply call it A1. Okay, so you can see A1 is equal to 99. Okay, so very simple. Now here whatever value you have, for example, if you have some value, let's assume that here you have value minus 98. Okay, then I can say that this is your A2. A2 is equal to minus 98. Anyway, so the point is simple, that this A is array which has total 20 integer values. This array A, this has total 20 integer values. Now this statement A, what we need to do? We need to convert this statement into first order logic expression. Okay, so this English statement we need to convert, we need to translate into first order logic expression. So this statement is saying every entry in the array A is non-negative. So what this is saying? This is saying that for every entry we are saying, for every entry, whatever entry you take, for every entry we are taking in the array, for every entry AX, we are saying that this AX is non-negative, means it is greater than or equal to 0. Already it is given that all the values are integer values. This is already given. In this array, all the values are integer values. Now this statement is saying every entry is non-negative, means for every entry you are saying that this entry is non-negative. So how to convert this? So very simple, you can simply write that for all n, you can simply say that an is greater than or equal to 0. Very simple. So this is how you can write. For all n, an is greater than or equal to 0. Remember, here something I want to tell you. If the domain is this, like let's assume the domain is A1 to AN. Let's assume this is the domain. Means if your domain has array values A1, A2 and so on A20. If this is your domain, okay, I am saying if the domain is this, then this statement you can simply write as for all x, x is greater than equal to 0. Because remember, if your domain is this, I am saying if the domain is this, then this statement every entry in array is non-negative, you can simply write as for all x, x greater than 0. If your domain is this, because ultimately what this statement says, this statement basically says that A1 is greater than equal to 0, A2 is greater than equal to 0 and so on. Okay, means every value, okay, A20 is also greater than equal to 0. So this statement is saying A1, A2, A3, A4 and so on, A20, all the entries in the array, these are non-negative. So remember, if your domain is A1 to A20, if your domain is this, then you can simply say that for all x, because x is a variable which refers to the domain, so this x, this is now entry in the array. Okay, because if your domain is A1 to A20, then whatever variable you will take, that will refer to this domain. So now this variable x, this is entry in the array, and we are saying every entry in the array is non-negative, means for all x, x greater than equal to 0. But you can notice this is wrong. If your answer is this, if this is your answer, then this is wrong. Why? Because this will be the correct answer if your domain has array values in the domain, if your domain contains array values. But you can notice that our domain has integers from 1 to 20. This is our domain. So please understand that in the question, the domain contains 1 to 20. So if you notice the domain, this is the given domain. This is the given domain. In the domain, you have 1, you have 2, you have 3, you have 4 and so on, you have 20. This is the domain you have. In the domain, we don't have A1. In the domain, we don't have A2. In the domain, we don't have these things. In the domain, we have 1, 2, 3 and so on 20. This is the domain. Now what this statement is saying? This statement is saying that A1 is greater than equal to 0. A2 is greater than equal to 0. Means all the array entries are greater than equal to 0. Similarly, A20 is greater than equal to 0. So how to write this statement? Every entry in array is non-negative. How to write this? Very simple. The domain is 1 to 20. So you can simply write as for all n, or I can say for all x. You can simply write for all x, ax is greater than equal to 0. Because this x now, this is a variable in this domain. So this x can take 1 to 20. These values this x can take. So finally I can say for all x, ax is greater than equal to 0. So this is what I want to say. For the first part, this is a common mistake. If your answer is this, for all x, x is greater than 0. If your answer is this, then this is a wrong answer. Okay, this answer will be a wrong answer. And if your answer is this, if your answer is for all x, x greater than equal to 0, if your answer is this, then that is wrong answer. And if your answer is for all x, ax is greater than equal to 0, then this is the right answer. Okay, so this is the point I want to tell you. Now remember, this will be answer if domain is if domain contains array values. Okay, so this answer will be correct if domain contains array values. So very simple, you can say this answer will be correct if the domain contains A1, A2, A3, A20. Means if the domain contains array values. But because in the question, the domain contains, you can see in the question, the domain contains 1 to 20. It is given to you in the question. The universe contains 1 to 20, integers from 1 to 20. So that is the reason the correct answer is this for the first part. Also, if you have written some other variable, that is also fine. See, this is the correct answer. For all x, ax greater than equal to 0. This is also the correct answer. Now, this is a bounded variable. So you can rename it. There is no problem. Because this x is a bounded variable, you can call it for all x, ax greater than 0. Or you can write it for all y, ay greater than 0. Everything is fine. All of them are correct. If your answer is for all n, an is greater than 0, that is also correct. So remember, if this is your answer, that is also correct. If this is your answer, that is also correct. If this is your answer for all n is greater than equal to 0, this is also correct. Because all these are bounded variables and they refer to the domain. So you can notice this is your domain. So whatever variable you take, variable x, variable y, variable n, whatever variable you will take, that will refer to this domain. So all these are correct answers. Because this is a bounded variable, this x is a bounded variable, so you can rename it. You can call it, you can rename it y, you can rename it n, everything is correct. So any of them is your answer, then that is correct. If your answer is this, that is wrong. Okay, so now let's see the next part. The next part is saying there exist two consecutive entries in A where the larger entry is twice the smaller. So the question is saying in this array, see, read this statement too. This is saying that in the array, there exist consecutive entries. There exist. Okay, so we have there exist consecutive entries, means somewhere you have consecutive entries. Okay, so let's assume this is n plus 1, these are consecutive entries. So there exist two consecutive entries in A, where the larger entry means this value means an plus 1, this value is twice the smaller value, Okay, so remember this value, let's assume this value is some value, let's assume this value is p and this value is q. Then it simply means the larger value is twice the smaller value, p is equal to 2q. Means I can say an plus 1, this value is equal to 2an. Okay, so very simple. So how to write this? There exist, so very simple, you can say that there exist n, or I can say there exist x, no problem. There exist x such that what will happen? There exist x, and remember the domain is 1 to 20, this is the domain. So there exist x such that ax plus 1 is equal to twice of ax. So very simple, this is your answer. So you can write like this, because you can see the statement is saying there exist two consecutive entries. Means if one is n, then automatically the another will be n plus 1. There exist two consecutive entries such that the larger is twice the smaller. So very simple, you can say there exist x such that ax plus 1 is twice the ax. Okay, so very simple. So this is your statement. So for the second question, the answer will be there exist x such that ax plus 1 is equal to ax. If you have written this, that is also correct. If you have written, for example, there exist n, an plus 1 is greater than or is equal to 2an. If you have written like this, that is also correct. This is also correct. This is also correct. Both are correct. Okay, so no problem, because anyway this x is a bounded variable, you can rename it. This x you can replace with n, no problem. So if you have written this, there exist n such that an plus 1 is equal to 2 of an, that is also correct. If you have written this, there exist y, ay plus 1 is equal to 2ay, that is also correct, because anyway this is a bounded variable, you can rename it. Okay, now let's see the next one. The next one is saying, now this third one is saying the entries in array are sorted in strictly ascending order. So what it means, in this array all the entries are sorted in strictly ascending order, means this a1 is less than a2, this a2 is less than a3, and so on and so on. A19 is less than a20. So this is the given statement. The statement is saying that the entries in array are sorted in strictly ascending order. Strictly means I can say a1 is less than a2, a2 is less than a3, and so on. A19 is less than a20. So we need to write this, we need to translate this in the first order logic. So if you want to translate this statement into first order logic, then what you can do? See, we are saying that all the entries are like this, means the array is sorted in ascending order, in strictly ascending order, means a1 is less than a2, is less than a3, and so on, is less than a20. So how to do this? Very simple. What you can do? You can simply say that for all n, you can say that for all n, you can simply say that an is less than an plus 1, right? Means every entry is less than its next one. This is what you can do. You can think like this. I can say basically in this array, every entry is less than the next one. So I can say like this, that in array A, every entry is less than, is strictly less than, or I can say is less than the next one. Okay, so very simple. Every entry is less than the next one. This is the statement, right? Because every entry is less than the next one. Every entry is less than the next one. So you can notice whatever entry you take, that will be less than the next one. So in A, every entry is less than the next one. So what you can say? You can say for all n, whatever n you take. Remember, n is from 1 to 20. This is your domain. So your domain has 1, 2, and so on 20. And so whatever variable you take, that variable will refer to this domain. So this variable n, this refers to this domain. So we are saying for all n, an should be less than an plus 1. Is this statement correct? Is this one correct? So think about it. Is this correct? If you got this answer, then this is wrong. There is a problem here. What is the problem? Let me tell you. So we are saying that basically this is what you want. You want that a1 should be less than a2, should be less than, and so on, should be less than a19, okay, and that should be less than a20. This is what we want in the option C. This is the statement C. Now if you are writing like this, if you are writing that for all n, if you are writing that an is less than the next one, if you are writing like this, then there is a problem here. This expression is wrong. There is a problem here. What is the problem? Let me tell you. See, this n is a variable. This n will refer to the domain, right? And the domain contains 1, 2, 3 and so on 20. These are the values in the domain 19, 20. So this n refers to this domain. So this n can take these values. This n can take 1, n can be 2, n can be 3 and so on, n can be 20. This n, this can take these values. Now when you are writing that for all n, an is less than an is less than an plus 1, where is the problem here? In this, where is the problem? The problem is when n equal to 20. Because this 20 is in the domain. In our domain we have 20. So this n, this can take the value 20. So the problem will happen if n can take value 20, because we are saying for all n. In this domain, for every value in this domain, we are saying that n is less than an plus 1. So when n will take the value 20, then basically what we are saying that a20 is less than a21. A20, we are saying this. We are saying a20 is less than a21. But this is invalid. This is not even element in the array. Your array has only 20 elements. If you notice the array, this array A, this has only 20 elements. Okay, so this only has 20 elements from A1 to A20. These are the only elements. We don't have A21. There is no A21. So this A21, this is illegal. I can say this is illegal, or I can say this is invalid. Very simple. So you are saying, remember, when you write like this, for all n, for every n, you are saying that this is less than the next one. For every n, you are saying that an is less than the next one. An is less than an plus 1. Then what is the problem here? The problem is because you are saying for all n, means for every element in the domain you are saying. In the domain we have 20 also. So you are saying a20 is less than a21. But you can notice this a21, this is invalid. In the array we don't have a21. So you can see this a21, this is invalid entry. This entry is invalid. Or I can say it's like in C programming, you know, there is something called array out of bounds. You may have heard about it. This is like array out of bounds error. So there is a error array out of bounds, something like this. Okay, so this is, you can see, because this a21, this is not even a valid entry. In the array we don't have a21. So that is the reason I am saying that if you have written this statement, then this is wrong. Okay, so if your final answer is this, if this was your final answer, then that is wrong. There is a problem here, and this answer is wrong. So I hope this point is clear. Why this answer is wrong? Because we are saying for every n, for every value in the domain we also have 20. So for every value you are saying that an is less than an plus 1. There is a problem. The problem is you are saying a20 is less than a21. But this a21, this is invalid. In the array we don't have a21. So this is invalid entry. So that is the reason this answer is wrong. So what you can do then? So what should we do? So you can make some changes. So you can see this answer is definitely wrong. What changes you can make? You can simply say that your n, if your n is from 1 to 19, what you can do, you can simply say that if your n is from 1 to 19, then that is less than an plus 1. So see what changes I am making. I am making this change that for all n, if this n is from 1 to 19, if this n is from 1 to 19, then there is no problem. Now I can say that an is less than an plus 1. So this is the correct answer. See what I am saying. I am saying that for all n, if this n is from 1 to 19, if this n, whatever value of n you take, so this is your domain. In the domain you have 1, 2 and so on. This is your domain 19, 20. This is your domain. So n refers to this domain. Now I am saying that if this n is from 1 to 19, then an is less than an plus 1. Now you can automatically notice what will happen. If this n takes value 1, okay, if this n becomes 1, then if you take n equal to 1, then what will happen? If I take n equal to 1, then a1 is less than a2. So if I take n equal to 1, then I will get an is less than a2. If I take n equal to 2, then what I will get? Then I will get a2 is less than a3. And so on. If I take n equal to 3, then what I will get? I will get a3 is less than a4. So I will get a3 is less than a4, and so on and so on. If I take n equal to 19, because I am saying for all n, if n is from 1 to 19, if n is in this range, then an is less than an plus 1. So if I take n equal to 19, if I take this n equal to 19, then what will happen? Then a19 is less than a20. So you can see then what will happen? You can see then this a19 will be less than a20. So this is what will happen. Okay, so very simple. I hope you understood. So this is the change that you can do. So very simple. In this question, the entries are sorted in ascending order. For this third question, you can simply say that for all x, you can say if x is from 1 to 19, if this variable x is from 1 to 19, if this is the range, then what will happen? Then you can notice that this ax should be less than ax plus 1. Means every entry is less than the next one. Okay, so this is your answer. For all x, if x is in this range, then ax is less than ax plus 1. If your answer, if you have written this answer, if you have written that this answer you have written for all x, you are saying that ax is less than ax plus 1, every entry is less than the next one. If you have written this answer, then this answer is wrong. This answer is wrong. Why this answer is wrong? I told you, because in this answer you can notice a20 is less than a21, but we don't have a21 in the array. We don't have the entry a21. A21 is invalid entry. So that is the reason this answer is wrong. And finally your correct answer will be for all x, if x is in this range, then ax is less than ax plus 1. Let's see the next one, the fourth one. The entries in array are distinct. All the entries are distinct. So how to write this? So the entries are distinct means what I can say? I can simply say that for all entries, whatever two entries you take, they will be distinct. In the array, whatever two entries you take, they will be distinct. Means I can say for all m, for all n, whatever two entries you take, they will be distinct. I can say am is not same as an. Okay. Is this correct? If I write like this, is this correct? Let me tell you, this is wrong. This is wrong. Why this is wrong? Because actually here you can notice m comma n can be same also. When you say for all m, for all n, here m comma n, they can be same also. Okay. So you can see this is wrong, because what this is saying that for all m comma n, am is not same as an. This is wrong. The reason is simple, that m comma n can be same also. Actually what we should say, basically we want to say that this a1, this is different from a2, okay, and this a1 is different from a3. So basically what we want to say that am is different from an whenever m is different from n. Okay, whenever m is different from n. Simply this is what we are saying, that if m is different from n, if the index are different in this array, if m, let's assume this is the array, this is the index, and this is the index n. Okay, so and so on, this is the array. Now we are saying that if m comma n are different, then what should happen? We are saying the entries are distinct. Means if the index is distinct, these entries must be distinct. Means this entry am, this must be different from this entry an. So I can say if m is not equal to n, then this am should not be equal to an. So this is what we should write. So your final answer will be what? The final answer is going to be, I can simply say that for all m, for all n, you are saying that if this happens, if m is not equal to n, if this happens, then what will happen? Then am will not be same as an. Okay, am is not same as an. So this is the final answer. So this is the answer. Okay, for all m comma n I am saying, for every two entries I am saying, for every two entries, if the index is different, if m comma n are different, then am and an, they are also different. So this is your statement fourth. So all the four statements we have seen, every entry in the array is non-negative, means for all n, an is greater than equal to 0. It means that for all n, an is greater than equal to 0, means every array entry is non-negative. And we are saying there exist two consecutive integers such that the larger is twice the smaller. That also you can write. There exist n such that an plus 1 is equal to twice of an. The entries are sorted in ascending order. So that you can write like this, that for all n, if n is from 1 to 19, then an is less than an plus 1. Means every entry is less than the next one. Okay. And the final, the entries are distinct. Means for all m, for all n, if m comma n are different, then their am and an, they are also different. So we have seen this question, we have seen all the parts, all the four statements, all the four English statements we have converted into first order logic. If you have any doubt, you can put your doubt in the comments. Okay, so don't keep any doubt. If you have any doubt, just put your doubt in the comments. I will answer your doubt. I will reply to your doubt. Okay.